In this video, we're going to go through some more examples for the permutations and combinations. If you have 5 boys and 4 girls and you want to arrange them on a bench, it's the same as having just 9 people if there are no restrictions. They can sit anywhere. We could also denote that as 9p9. So the answer is, as previously in the last video, going to be 9 ways of choosing the first person, 8 ways of choosing the second person, etc., etc. So the answer is 9 factorial. Now, if you want to alternate the boys and girls, because there's 5 boys and 4 girls, there will have to be a boy on each end of the bench. So for the first person, we have a choice of 5 as there's 5 boys. For the second person, we have a choice of 4 because there's 4 girls. And for the third person, we have a choice of 4 because there's only 4 boys left. And then 3 because there's 3 girls left, and so on. So it could also be written as 5 factorial times by 4 factorial. And the final answer is 2,880. How many arrangements are there if the boys and girls are in separate groups? Well, we treat all the boys as one group and all the girls as another group. So there's effectively 2 items to rearrange, which is 2 factorial. However, there are 5 boys in the boys group, and these 5 boys can also be arranged in any way. So we have to times the answer by 5 factorial, and likewise there's 4 girls that can be arranged in any way, so we have to also times it by 4 factorial. This is the same as writing 2 times 5p5 times 4p4. So the final answer is 5,760. And how many arrangements would there be if Anne and Jim wish to stay together? Well, in this scenario, we treat Anne and Jim as one unit together. So that effectively means we've only got 8 people to choose from, or 8 items to choose from. So that would give us 8 factorial. But Anne and Jim can be organised in any way. You could have Anne and Jim or Jim and Anne. So we also have to times it by 2 factorial. And that's the same effectively as saying 2 times 8p8. So the final answer is 80,640. Next, we're going to go on to arrangements with repetitions. So first we'll show one without any repetition, dairy. There are no letters that are repeated. And if we want to rearrange the letters, there are 5 ways to choose the first letter, 4 for the second, etc. So the answer is 5 factorial, which is 120. And I've also shown that you'd get the same answer if you use the formula. Next, we move on to the word Malaga, but Malaga's got 3 A's. So how does this affect the answer? If we write it like this or this, it still spells Malaga, even though the A's are in different positions. So then we look at how many ways we can organise the A's. And as you can see, there are 6 ways to organise the A's, or 3 factorial. So in this circumstance, we also have to remember to divide the answer by 3 factorial. Now, if we write the equation like this, 6 times 5 times 4 times 3 factorial, it's a lot easier to cancel the 3 factorials out. So the answer is just 6 times 5 times 4, which is 120. So if we want to rearrange the word Mississippi, there are 11 letters. So if they were all different, the answer would be 11 factorial, like before. However, there are lots of repeated letters here. There are 4 I's, 4 S's and 2 P's. So we have to divide the answer by 4 factorial, 4 factorial, 2 factorial. The final answer is 34,650. How many arrangements are there of the word remand? Well, all the letters are different, so it's fairly simple. It's 6 factorial. But how many of these arrangements begin with RE? Well, if we've already set the first 2 places, we've only got 4 letters left to organise. So the answer is 4p4 or 4 factorial, so 24. But how many of these arrangements do not begin with RE? Well, for that we need to take the total number of arrangements and subtract the number of arrangements that do begin with RE. And we've worked both those answers out in the previous 2 sections. So it's 6 factorial, take 4 factorial, which is 696. So how many arrangements can we make if R and E are together in order? Basically, this means that we're taking RE as one unit, so there are 5 units, but the RE can be in any position. It could be in position 2, 3 or 4. So this effectively is the same as saying 5p5, which is 5 factorial, which is 120. What about if RE and M are together in any order? Well, in this scenario, RE and M is treated as one unit. So we are organising 4 different items, which is 4p4. However, RE and M can be in any order. So there will be 3p3 ways of organising those. So the answer is 4 factorial times by 3 factorial, which is 144. And if R, E and M are not to be together, we have to take the total number of arrangements, which we worked out in part A, and subtract the amount of arrangements where R and E and M are together, which we worked out in part E. So it is 6 factorial, take away 144, which is 576. Well, that's it for this video. Thanks very much for watching. I hope it has been of help. I'll hopefully see you on the next video with some more examples. And in the meantime, if you could like and subscribe, I'd really appreciate it. Thanks ever so much. Thanks, guys. Bye.